Okay, and then we solve a Leetcode question 133 clone graph. So giving a reference of a node in a connected undirected graph. So that's one point that we should note here. Undirected, right? If you look at my video, show me video on graphs now, you will be able to tell what is a directed and what is undirected graph. Return a deep clone of the graph. Almost a graph no. The graph class will contain the integer value and then a list of its neighbors. A test case format. For simplicity, the node value of the same is the same as the node index. For example, the first node is of value 1, the second node is of value 2, and so on. The graph is represented in the test case using adjacency list. If you look at, I have a video that I will link, maybe I'll link to this video about adjacency list and what it is, and I explain into it. And defining adjacency list, what I say, right? Basically, I say so my example of what? Example of a question. Now I'll share a question where I emphasize on my graph where we can form it into an adjacency list, and it will be something like this. Right. Every time we BCC. So 1 with 1. Or mark as a 0 indexed, 1 indexed array. So this is also an important point to note. Right. Array. Some amount adjacency list be say we say arrays number start here free. I say arrays index now starting free 0 1 2 3 4. Right. And if we want to represent this, we say in adjacency list, it will something like this. 1 has a connected to 2 and a connected to 4. Right. In the event say we are 1 here, the list, right? This is the value of 1. The class of a node will look something like this. 1 connected to 2 and a 4. So 1 connected to 2 and a 4. Here by 2 2 connected to 1 and a 3. Alright, here by 3 connected to 2 and a 4. Here by 4 connected to 1 and a 3. If you represent a graph in adjacency list, this is how it will look like. And this is exactly what it is looking like. I will say 2 4 1 3 2 4 1 3 2 4 1 3 2 4 1 3. Right. Basically, question where you say including graph. You basically just make a copy of the graph. And on the mouse, any of these nodes, right? Wait mama 1, wait mama 2, wait mama 3, wait mama 4. And based on that, clone it. Make a copy of Sarah. And here 1 say and I can say create a copy of all of this array, because you can traverse with my kohase with 1 with many 2 4 with many 2 1 with my kohase, because the graph is undirected. The 1 with my kwa na yama 2 with my 1, right? With my 1 with 2, 3, 4, because we know say from 1 with my 2 with my 4. If we 2 so I with my 1 with my 3. If we 3 so I with my 2 with my 4, right? And see now we're cloning at the end. But we say this approach you can either use DFS or BFS. This is depth first search and as a breadth first search for graph traversals. We under DFS we use to stack, we use to queues, right? I think it's a mess of one with the way, but it's not very different the approach that you use to solve. First, you remember one of this node into but create a copy of this, create a copy of the node now. Now for here, we'll go through, we'll assign a copy 2 4 no account, right? And you will store our values within a like a dictionary, right? A hash table or a dictionary. Right? To be stored in a dictionary. Anytime you when you're two now store, anytime you will be where you hear two be and you can just reference it from the hash table. Right? So let's look at how you can solve this particular question. Question we basically is testing your knowledge on DFS and as a BFS, how to traverse graphs. So let's go. And if you don't know much about DFS and BFS, maybe I'll do a video about DFS and BFS. But all you have to do is read more about DFS and BFS to get more context. Okay, so how we are going to solve this. So first, let's create a dictionary to store our results. So if I'm saying visited, we go to this. And then let's create a DFS algorithm that takes in node. Right. If not node, return none. Right. If node invisited, return visited node, right? But if it's not visited, then we create a cloned copy. Clone copy where node node.val, right? You create the first value, this value 1, right? Because you see node class BI has a value and it has neighbors, right? So store, say we have found this, so let's store it in the dictionary for future use, right? And for each neighbor in node.neighbor, I'm misspelling neighbor here. For each neighbor in node.neighbor, cloned, because you see here clone, you see here cloning here only this value. You see I can say per se add neighbors to it, right? We share clone object now a value in a one neighbors. You see here clone object itself. You see per se add neighbor into clone dot neighbors dot append, because it's a list, right? Neighbor and a list. Neighbor is a list, right? Neighbor object in a list. Append, let's find for DFS in itself. Neighbor. Interior, then we returned cloned, right? So this is basically a modified DFS traversal, right? There's that way you're cloning, some things are going on here, but under normal circumstances, without this, you have your DFS, right? In CCI, you will just return yes. So this should be a valid solution for cloning. So let's see. All right, there is a typo in here. Visited was not spelled correctly. Yes, this is how you solve clone graph Leetcode 113. See you in the next one. Bye.